Welcome to Group 1 of Capstone 2016. My name is Daniel Meyer, and I will be explaining our control system today. It is called the Hotbox. Some other group members include James Dickens, Michael Nugent, and Jay Walker. The Hotbox is a representation of a psychrometric test chamber used for testing components in harsh conditions before they are implemented into the field. Currently, OSUIT does not have a trainer for cascading control as a thermal control trainer or as a wireless communication trainer, and the Hotbox could be utilized for any of the three. Some of the components in the Hotbox include the heating chamber itself, the control box, and then the HMI and the software. Inside of the control box includes the CDAC, which houses the digital output and analog input cards. The digital output card being used is the 9474, which switches the relay on and off. The relay being used is a solid state relay, which controls the heating element. The power supply being used is the 1606 Allen Bradley, and the analog input card being used is a RTD card, which is the 9219. A little bit closer look of the control box. You can see the CDAC itself at the bottom, and you have your two input and output cards. You've got the power supply and then the solid state relay here. On the back side of our heating chamber, we have our ducting. Inside of the ducting, we have a deconstructed heat gun, which was a 1200 watt Wagner heat gun, which resembles this. Inside of the heating chamber, you can see our ducting, the substance being controlled, and then you have a RTD, which is in the ducting, or a thermocouple, which is in the ducting, and then one in the substance itself. This thermocouple here is used for the inside or the outside control loop in the cascading system, which controls the inside loop of the substance. I am now going to hand it off to James, who will be describing the rest of the system.
Alright, what we've got is we've actually got right here, we've got the heater capacity, which shows what the percentage of the full capacity of the heater that is currently being utilized. We've got the current temperature of the chamber itself as read by the thermocouple, and then we've also got the current set point of the heating chamber, which is controlled by the material temperature. We've got the material temperature showing right here, the material set point right there. Whenever you put the material set point and the temperature are compared by the program, and that is used to determine what temperature the heating chamber needs to be to bring the material temperature to that temperature and to maintain it. If we go to the actual program, see here, these are the actual inputs from the CDAC. They come in here where it goes into a buffer. This buffer averages the last 50 samples and is continuously gaining more samples. It is outputted. These are actually what you see on screen. These are connections to the indicators on screen. We then go back over. That is inputted to a PID right here that can range its output anywhere from 50 to 250. We have our material set point here. The PID outputs right there. We come up, this is the actual output that you see on screen. That then goes into a second PID. This PID has the set point from the first PID the output from the first PID, and also the chamber temperature. And then that is used to control the actual output of the heater. This is done by the signal from that, which is anywhere from 0 to 100, comes out, goes through another buffer. This one, again, averaging the last 50 samples. Comes out. These are the displays that you see on the front screen. That number is comes out right there. We have a timer that is just continually running. The output right here going from 0 to 100 every 5 seconds, or actually every 2.5 seconds. And it's comparing this output to the output here. If the output here is lower than the output, it'll turn on the element. Once this number rises above it, it'll shut it off, therefore giving a proportional control of the element. To make sure that this program does not stop at an incorrect time, when you actually shut down the program, it'll wait till the element shuts off and then shut down the program. The whole program is set up with external data points that are transmitted, so that all of the information that you can see on this front screen is also shown remotely. This is actually completely wireless. It's showing your heater capacity, material temperature, chamber set point, and there is your material set point. You can take and change your set point for your material right here, and that change will instantaneously be back over here. If you change the set point on this side, it will change it over here. So you can both control and monitor the system both directly from the local control HMI or remotely.
Here's another look at the overview of the wiring. I think that wraps it up. Thank you.